It's my absolute honor to be here, and I cannot claim any expertise in information theory. I'm a little bit aware of it and very much fascinated by it. But I'm also biased, and I could say that I'm also fascinated by radios and saying that we absolutely, from the wireless domain, we need information theory, maybe more than ever. On the other hand, for people who like to continue working in information theory, I think we offer a lot of challenging, interesting problems. So maybe that's a reason anyway to be allowed to speak about radios for information theory experts. So I'll talk a bit about species and habits, and indeed part of the radios today are supposed to be embedded, low power, and connecting everything that we didn't connect in the past and that we hope can serve society one way or another. So it's going to be 4 parts in this presentation. First, going to give a little bit of introduction on the radio. Being a professor, you want to be a bit educational and repeat some things. I'll talk about different species, living and fantastic species, and habits of these radios. Then I'll talk about the green radio, which I believe is the most important radio we have for now and for the future. And then I will talk about Radio Corridor, which is a special radio coming from Flanders, and I'll explain what Radio Corridor is. And last, if there's some time left, something about the future. So what is a radio? Let's first start with a definition. And there are actually 2 kinds of definitions for the radio. One is reflecting the electronic device for transmitting and receiving electromagnetic waves with the intention mostly to communicate information. But the second definition is also referring to the sound that is communicated by radio waves. So when we talk, we heard something on the radio. We don't hear the electromagnetic wave, of course, but it's about the things that are said on the radio. And this definition also said that broadcast radio astonished and delighted the public by providing news and entertainment with an immediacy never before thought possible. So in this presentation, I will talk mostly about the device side, but I will also talk about some radios that fit in category number 2, namely, or in definition number 2, namely Radio Corridor is part of that one. And then there are different species of radios. I'll talk about them, but there's 2 main categories. There is the living species. The living species, they respect the laws of physics and of information theory. But at least as important, I think, is the fantastic species. And these result from the imagination of researchers and of artists. The tip is that you could avoid confusion, or you can also decide not to avoid confusion. In information theory, it's sometimes good to have a lot of entropy. So I will be spreading a little bit entropy here as well, in spreading confusion about are these things living species or fantastic species. So this is based on a true story. It's not necessarily completely true. And what you see here is an image of Ada Lovelace, who's supposed to be the first real coder or computer programmer. And she said that intuition and imagination are critical to effectively applying mathematical and scientific concepts. She valued metaphysics as much as mathematics, viewing both as tools for exploring this unseen world around us. So honoring one of my role models who was writing a computer program before even a computer was there, I'm also honoring everyone who has imagination to find out in the fantastic species some things that may become living species afterwards. So what is radio based on? I think, we know there's Maxwell's theory, and Maxwell said there's nothing more practical than a good theory, and I think we all agree with him. Now, Maxwell himself did not make the theory an experiment, but Hertz did, and Hertz claimed that it's of no use whatsoever, a radio. This is just an experiment that proves that Maestro Maxwell was right. We just have these mysterious electromagnetic waves that we cannot see with the naked eye, but they are there. And so he didn't expect any impact from that. He said, well, I don't think it will have any practical application. Fortunately, the theorist, Maxwell, he was a believer in the practical applications. Well, and then next to that, of course, we have Claude Shannon who came and who also brought us a theoretical law. And I would say also there's nothing more practical than a good theory. I think this theory has helped us so much in bringing the radios to what they can do today. By bringing the radios digital, but also by firmly believing in Shannon's law and that it's a place where we can go to find this capacity, has helped us to come to very efficient radios and make them much better than what we would ever have believed in the beginning of the radios, in the beginning of last century. Now, knowing this law, I will be very careful in saying anything about it, but I would say living species, normally capacity should be below infinity for all kinds of reasons, even if bandwidth is infinite. Well, there are some claims sometimes made, even in literature, that seem to suggest that there are fantastic species that could offer capacity equal to infinity. Well, I think for that, we refer to Radio Maria. Are there any people who know Radio Maria here? Yes, some people know Radio Maria. Well, I think it's even, if you look very well to the picture, so it's Maria over here, it's even receiving in DAB today. They sell these DAB radios for the Radio Maria. So I think if you want to hear about radios offering capacity equal to infinity, maybe you contact Radio Maria. And theologically, they can do it, but physically, I don't think so. Okay, so why is a radio so interesting? And if we relate it to information theory, well, thanks to radios, bits can travel fast, and they can also travel far, but they need energy to do that. So suppose you are here in this movie of Sandra Bullock in Gravity, you're completely lost in space. You could get in panic, but not if you have people who know about radios and who know about information theory. Because they will tell you, no panic. If you have an antenna, you can have waves that transport your information to get some help for you, and these travel at the speed of light, so it will go very fast to reach the Earth. And moreover, you will be able, since you're alone, you will be able to have a lot of bandwidth. Information theory people will say you can get a lot of capacity on your channel. Now, a bigger problem is that the receive power is going to go down drastically. There also we could say, well, lucky you, you're in free space, because if you're not in free space, it even goes down more drastically. But in free space still, we see here is a problem that you have the distance to the square, and most is even worse. So that's a big issue, and that's why we need to get the best out of radios, is because we lose all the power somewhere in the air. Now, this is also something that is very often used in literature and in research, is to use this factor 2. I think it's only in free space, so in science fiction most of the time. And also to use something which is an isotropic antenna. Also an isotropic antenna is something which does not exist. It's a fantastic species. It doesn't exist in the real life. But anyway, it's a guide. A starting point, I would say, is that we can transmit things with waves. If you here let Shannon do his work, you have a lot of bandwidth. Temperature is rather low, so you won't have a lot of noise, so you would have a lot of possibilities still to transmit information. Now, what we learn for sure is that low power and wide area, they do not go together very well. And that is exactly where now a lot of these new radios we are developing for embedding into all kinds of things like this bird nest, for example, they try to combine low power and wide area. And this is just by looking at a simple formula, this is a contradiction. So what can we do? I think we should do whatever we can to still work with as low power as possible. And here I'll give you an example of a rather recent radio. It's the IO3 solution. We measure the health of trees. This is a prototype. We're going to hopefully have better things in the future. And what we do is we try to follow up what the tree is doing, whether the sap is flowing well or not. What you see here is not an antenna, it's actually a thermometer. The antenna is just in the box, and we measure both on the tree and outside of the tree, and you can see what happens with the health of the tree. Interestingly, we can plot what are the trees doing, and some of these trees are measured by people we don't know. This is a crowdsourced thing. We have been offering these like IKEA packages, do it yourself, and now and then on the map we see more trees popping up, being connected through a low power wide area network and measuring the health of trees. What is the biggest problem with this? Next to that, we need to have the good biological parameters. The problem is whatever we do currently, every 6 months, we need to replace the battery. So power and energy is the main problem of this kind of remote IoT devices today. And this is not doing a lot of measurements. It's measuring temperature just a few times. So it's not good enough for what we want to achieve in the future. Many things we can do, but point number one is look at what's happening. Who is guilty for drowning the battery? Well, and that, unfortunately, the radio is the one who is guilty. Even being a wireless expert or passionate about wireless communication, I admit the radio is the one who is really here guilty for using all the power and the energy. If you look at this measurement, what we have done is as a function of time, we have measured the transmit power and the other power, all the power components actually. And here, this part is the transmit. You see there is a few receive windows, and you see that the sensing itself, it's extremely small, and you hardly see it. And it's sleeping most of the time. The sleep is very, very low power, you don't see it. But what is really both in terms of power, so the maximum we measure here, and in terms of energy, is what is drowning your battery. It is the radio that is guilty. And for IoT devices, more than for the 2G, 3G, 4G, 5G phones, this is even more the case because we want to hear what they're experiencing, so they need to transmit all the time. And it's the transmitter that needs to put the energy in the waves to transmit the information. So that's the bad thing about IoT. Mostly the radio devices need to transmit, the nodes need to transmit, which is bad for energy and for power. So what can you do about it? Well, I think we definitely need to go to the next chapter and very short, some notes about what do we need to do to get some green radios. Well, if we want to increase energy efficiency, first we need to address the big spender. And the big spender clearly here is the transmitter. Could we do with less power at the transmitter? Well, and there, of course, the answer is yes, we should try to do that. And one thing for sure is, could less suffice, is need to make sure we get the best out of the channel that is there with the minimum transmit power. It means listen to Shannon and try to get the best out of what you can get. Now, if you look at the power and the relative power consumption used in an IoT node, a typical IoT node, so not one that is continually measuring, so one that is doing a measurement now and then you see that in power, transmit is really the main thing. Receive is much less. Sleep in power is extremely low. And processing also is extremely low. So this helps us, I think, to already understand what can you do to build a green radio. First, listen very carefully. So try to reduce the transmit power and still hear it correctly at the other side. So have very good receivers and sleep as much as possible. So even if people now would say, this is after lunch, it's a time to do a bit of sleeping, I would say, go ahead. It's very important for green radios that you practice what you preach, so sleep as much as possible, I would say. So this is for power consumption, and I think already looking at what we see here, things we worked on, like together, Frans, we worked on turbo coding, and in the beginning people said, well, it's interesting as an idea. It was a mysterious thing. Information theories in the beginning did not really fully understand, but very practical people like I used to be wanted to still make it work. And the main thing was, will you not burn all the energy in the processing? And then does it make sense for whatever you gain on the channel? I think in view of where we are today, I would say, yes, it does make sense, because processing power has been going down and down and down thanks to technology scaling. But for the rest, the laws of physics will not change. The laws of information theory will not change. So there, we can spend more power or more processing complexity, not power, to get most out of the channel, I think. Now, if you look at energy, here it looks a bit different because, of course, here time plays the role. If you look at energy, we still see that the transmitter of the radio is guilty for half of the energy budget. The processing is hardly visible, so definitely from that point of view, there is a reason to do more processing on on the note. The receive is also very small here. But you see that also the sleep becomes very important. So people who claim, yeah, we can neglect the sleep because the sleep is so low, you can never, in this kind of application, neglect the sleep. So other lessons learned, think before you talk. It's probably always a good idea, but also for IoT nodes, you don't need to talk all the time. You don't need to transmit all the time. If the measurements of the tree are mostly in line what is expected, you don't need to transmit 5 times a day. You can transmit once a week or even less. It's going to help a lot. And also sleep quietly. Think about a very good sleep mode and switch off whatever you can switch off if you want to have a longer energy. So another thing to do, of course, is if you're transmitting with less power, is to have a very good receiver. That's one of the things we have been working on, is reception with large arrays, massive MIMO. We have been doing that for 5G communication and beyond, but also for IoT, to reduce the IoT node transmit power. Well, since we can listen to faraway planets and stars with big antennas, we can do the same, I think, with IoT nodes. So building very good receivers, directive antennas, also for this unlicensed band, make a lot of sense. And so KU Leuven has been going around with these wireless transmitters. We've done nice experiments together with my colleague Sophie, who's also here. I think this is the building which is in the Arenbergpark, France, as well. And sometimes the antennas, if there's windy, they just come down, they completely break. Unfortunately, I have no images of that, but we never give up. I think we can build greener radios if we think smartly together with information theorists. So that was some technical part, but another definition of the radio is what is being said on the radio. And that is what we call in Vlaams, radio corridor, with a little bit of French in there, radio corridor. And what is said? Well, it's also known as coffee corner radio. I leave it up to you whether it's a living or a fantastic species. It's all the kind of news that is spread around coffee corners, in corridors. It's said that you don't need any electronic devices actually for communication. You can just do it in person as well. Some people claim that capacity does approach infinity for radio corridor or the coffee corner radio. It has suffered from pandemic restrictions, unfortunately, but it does not cause pandemic. So everybody knows that 5G radio is the cause for the current pandemic, but coffee corner radio is fully safe, so no risk for that. But so I leave it up to you. I'm going to say a few words about what I heard on Radio Corridor. I leave it up to you to decide whether this is a living or a fantastic species. So there's been some news, Frans Willems, about you on Radio Corridor, on your contributions on information theory in the Benelux and beyond. And I think one of these things I was told is that, Frans, you were the inspiration for Ludo Tolhuizen's first contribution to the WIC. And I think if I ask, is this a living or a fantastic species? I think Ludo says this is a living species. Do you agree with that? So you see, it's true, but yeah, you claim the solution is his. He seems to think the opposite. It's Radio Corridor, everything is possible. I think another part was that Frans performed his R&D in Leuven, where he brought to practice, when in Rome, do as the Romans do. And it's said that Frans has been practicing in Leuven, not only information theory, but also other things. Radio Corridor has not told me exactly whether he was more into the hand or the eyes of Fonske, and whether he was more a friend to Fonske and visiting Fonske, or more visiting the church behind. But I leave it up to Radio Corridor to explain that later on. Radio Corridor also told me that Frans has been the IEEE IT chapter chair from 2007 to 2017, and a valuable member since. And I think for people who know Frans, his contribution there, I think we all know this is a living species, it's absolutely not a fantasy. And yeah, of course, as we already said today, Frans has initiated this very successful series of Van der Meulen seminars. what also was on Radio Corridor is that the best IEEE European School of Information Theory ever has been organized under the leadership of Frans Willems in Zandvoort in 2015. Yeah. But I think the pictures kind of show that yeah. Okay. I also heard on Radio Corridor that it gave an excellent excuse to travel to sunny Barcelona the year after to get this kind of reward. That seems to be a true news. And then I think there is still some more news. There is actually some breaking news brought by Radio Corridor. And the breaking news is that Frans Willems is offered to be an honorary member of the WIC starting today. And I will read, it's for his leading scientific achievements in the field of information theory, education of and inspiration for Benelux information theorists, and his contribution to the organization of many events. Congratulations. So, to finalize this, is there anything to say about the future radio and how should it look like? Well, actually looking at what people expect from wireless communications in the coming years, definitely there is a need for future radios. We want to have monitoring and real-time applications where, as has been said by one of the speakers this morning, in security, it is not okay if now and then it doesn't work. It should always work. For wireless applications, we the same thing happening. We want to make dependable systems, autonomous driving cars, these kind of things. Depending on wireless communication, the reliability has to go up. Next to the fact that the reliability has to go up, there are so many of these AR, VR applications envisioned, whether they call it a metaverse or mixed reality or whatever. It will require a lot of data rates, so we'll need to see how to get there. And a lot of these things will also need location-based information because a lot of things become autonomous. You want to track and trace so many things. How will we be able to achieve that with radios? So what to do? Even today already on the information highway, this is what we envisage. We need new generations just because there is not enough bandwidth or whatever available, capacity available. So how could we do that? And I think one of the solutions that is being proposed is to explore new territories, very high frequencies going to millimeter wave and terahertz. And of course, it's like climbing a mountain, I think. Why do you go up a mountain? Well, just because the mountain is there, because there are some nice views. You might discover some new landscapes. And you have a bright open view, you have a bright open sky. There's a lot of bandwidth available. So I think definitely these are some reasons. I think scientific curiosity combined with the bandwidth is available is a reason to go up to very high frequencies. We should be aware, however, that Shannon always travels with you, always. Also, if you go up these very high frequencies. And sometimes, if the road is fully blocked and your SNR goes to 0, whatever bandwidth you have, you'll be in trouble. So I think for some of the applications which ask for a high reliability, I would be very careful to say, let's go up the mountain and we'll find it there. I think there's other radios needed, and one of the new technologies that we are developing in one of the European projects I'm proud to be involved in is radio weaves technology, where instead of putting everything in the cloud and bringing everything to central places, we do the opposite and we say, let's build in a radio weave, not only radios, but also compute power, storage, and so on, close to the application, so that we can bring it real time, real space, very reliable, and reduce the global bandwidth need, make it a local bandwidth need, also reduce the transmit power you need, and increase energy efficiency. I think this is a very good way to move forward, actually, to get to what we would call the future grown radios. So to conclude, I think you had lunch first. I hope there is some food for thought in how can information theory people and radio scientists help to build the green radios of the future. I would like to thank the organizers and all the attendees, and special thank to you, Frans. Frans, there's been some discussion in the information theory chapter while you were not there. We have been cheating a little bit on you. on how we could make your surname, Willems, be expanded in something that characterizes you. And we came to wijze informaticus, loyale leermeester, energieke menselijke schakel. And the reason why we had to find such a thing is because it's a kind of tradition that for people normally that youngly retire as a Ph.D. or for other reasons, we give them a small present, and it is there next to you from our chair, a small present, which is actually a fonske, a statue of Fons with an inscription, which in this case, the inscription is actually indicated here on the slide. So thank you for everything you did for IEEE Benelux chapter and the week.